So hi guys, today we'll be covering stacks, queues, sets, multisets, and if we get time, we'll try to cover maps as well, or else we might cover it tomorrow. So one thing I'd like to mention before we start the session is like do update the problem set every time you solve a problem. Like I think a lot of you are not really doing that. So just one thing I want to mention, update the problem set every time you solve a problem in the sheet. Okay, so I guess we can get started. So Jigyasa will get started on stacks and queues. So Jigyasa, I think you can take over.
So, hello. I think I'm audible, right?
Yeah, you're audible. Yeah.
I think my screen is visible, right?
Yeah, your screen is visible.
Yes, okay, fine. So,
Okay,
hello
great.
everyone. I'm Jigyasa Sourtha, and today we will be having a session on session 6 on stats, queues, and deques, and the rest will be taken by the other. So, in case if you have any doubt or any queries, please to ask, or you can also type in the chat. So, fine. Okay, so let's start. Okay, so okay, first before starting, let me ask. You can see the stack of coins, stack of plates. There is a can of tennis balls and probably a stack of books. So if you wanna add or remove, let's say from the stack of the coins, if you wanna add a coin or you want to remove the coin, how can you do that? So like anyone can write in chat or you can speak up. Like how will you add a coin to the stack of these coins, or how will you remove coin from the stack of this coin? Anyone? Okay, so let's say actually what you will do is whenever you want to add or you want to remove from the stack, you will always add at the top of the stack. That is the only possible option for you. When in the case of the stack of plates or a can of a tennis ball or stack of books. So now what is actually a stack? It stores a list of items in which an item can be added to or you can remove from the list only at one end, that is at the top of the stack. So if you want to add or you want to remove, you will do it from the top of the stack. That is the most recently added items are at the top of the stack. So let's say if I add any item right now, so that will be the topmost element. And if I remove, that element will be the one which is the one to be removed. So this works on a LIFO principle. LIFO means the one which enters the last will be the one to be out first. So the last element to be added is the first to be removed. Like, so there are some operations that stacks perform. First of all is push X. So what is push X? It add new items to the top of the stack. Let's say I have already a stack with an element one. Now I need to add an element two. So if you want to push it, you will call the push function. And here, instead of X, there will be the data type that you are using. For probably now we are using integer. So here it will be two. So it will push the element two in the stack, of course, at the top of the stack. This push function calls add the three at the top of the stack. Same way here, four, then here five, and the six. Like when you go for the another function that is pop, so you remove the top item from the stack. Actually, when you call a function pop, it will always remove the topmost item from the stack. And as you know, the one which is added the recent is the one which is the topmost item. So let's say earlier it had the stack had the topmost item as six. Now when you call the function pop, it removes the six. If you call again, it removes five and then four, and it goes so on. So what are the other operations that you can support by a stack? So first is the top, that is while calling the function, it will always return the element that is present at the top of the stack. While calling the function size, it will return the size of the stack. And while call a function empty, it will check whether your stack is empty and it returns a Boolean value. Let's say, let's try to see in this case, before calling the pop function, your topmost element is 6, and after calling the pop function, your topmost element will be 5. Like before calling the pop function, your size will be 6, including 1, 2, 3, 4, 5, and 6. And after calling the pop function, your size will be 5. And if you call the empty function, it will return the Boolean false as the your current now the stack is not empty. Okay, so let's do a question. It's asking you to reverse a sentence using star. So, okay, let's start. Okay, let me wait. I think my screen is visible, right? I guess you guys can see the Z board. I guess that board is visible, right?
Yes, it's visible.
Thanks. Okay, so let's see. Let me say you have been given a string S, that is hello world. And now you want to return the reverse statement, that is it should print out world and then hello. Probably it is like you will always you will print the words in the reverse order. So as from this, now how you can use the stacks? If you see what we are doing, the one which is added the last will be always written the first, and the one which is added first will be written last. And as you see, it is a string, and we have a spaces between these strings, like the blank spaces which are left. So what are we gonna do? We'll run a loop. Probably, okay, let me give you an example where you are gonna store in a stack. Let's say if I store the first hello in the first at the first place, the second place I store the word by using the push function. And when I call the pop function, it will first of all pop out the word. And then after popping it, the stack will look like this. And after calling again the pop function, like, sorry, you will call the top function. And after calling the top function, after calling the pop function, it will get removed. Now you will call the top function that will return hello. And after calling the pop function, this will probably make your stack empty. And so like this is how you are gonna use it. Probably how you will, first of all, this is how you initialize a stack. Actually, to initialize a stack, we always write a stack function with the, let's say, because as we are pushing the strings here, we will call the string data type and st. And by the way, if you need a header, actually, we are using bits std c++.h that already includes the stack in it as a header. But if you use the header as include iostream, then you have to include the stack. So what we will do, we'll start from I equals to 0 till I equals to the length. And here what we will be taking the first word. So how will you take the first word? You go on. Well, let me start from a loop. Let's say this is, I guess the length, let's say the length of the string is given. So I'll start from I equals to 0 for my string. And I'll store, I'll call a temporary string, say, let's say first of all, I'll call it temporary string W that will store the first word or will store the word. So as we have a string, hello, then you go for the string W. So we will start from the first letter and we'll store it in until you see a blank space. As we see a blank space, it means this is your first string to be stored in the stack. And then with the help of calling the push function, you will store it in the stack. After then, we'll again move as to the next ith element. We'll set W to the null after pushing it to the stack. We'll go to the next element, that is here is W. We'll again store it in until we see a blank space or our I is less than the length of the string. As we see, the world will be here. We'll push the world in the stack. Now, to get the top element of the stack, we will call the top function, which will return world. And after that, you will call the pop function that will remove this element from the stack. And again, you will call the top function that will return hello and use a blank space. Maybe to see this code, you can see we are running from I equals to 0 to I less than s dot length from I plus plus, and we have a string word. Actually, it's like every time we call it, it will be always be as a null string. Then we'll start until we get a blank space or its i's till it is s dot length. We will always add that character in our string. After that, adding that character into the string, we are also initializing the I2 plus plus, and we'll push that word to the start. After pushing all the words to the stack, what we will do, we will run a while loop until your stack is empty, because you cannot call an empty stack, and then you will first of all print out the st.top, and then you will pop the. I guess there are no doubts, right? Does anyone have any doubt in execution? Okay, I guess no. Okay. Now let's come to the next question, that is finding the next created element using stack. So what is this saying? First of all, you will be given an array, and let's say you have been given an array that is 4, 5, 2, 25. You have to print the next greater element for every element. And what is actually the next greater element? For 4, you have to search in the right of the array. The first element that you get, which is greater than 4, will be treated as the greater element. And let's say for 25, as there is no element right to it, of it, it will be -1. And if you're not able to find for any of these elements, you will substitute them as the next greater element. So they would say, what does that mean? Let's say you have an array 5 and 25, and you have to return an array such that for every element of the array, you should print the next greater element. Let's say if you have a 4, if you go from here, you will see a 5 is the next greater element. So you will write here 5. Or now when you come to 5, 2 is as 2 is smaller than 5, it won't be treated, but for 5, it will be 25. For 2, it will be 25. And for 25, it will be -1. But what if you had 4, 27, and 25? First, the next greater element for 4, it will be 27. For 27, you went to 2. There is 22 is less than 27, and 25 is less than 27, and now there is no element. So 27, you will write -1. For 2, it will be 25, and of course, for 25, it will be -1. So, okay, this is briefing now. Okay, let's ask me what you guys think can be the naive approach for it. Like, what comes to your mind when I ask for this question? Like, how could you guys solve this question? Anyone? So, say, okay, easily the naive approach will be whenever you are at ith element, you will always run a loop from I plus 1 till the end to see if there exists an element that is greater than 4. So if I'm at 4, I'll run my loop from I plus 1 to, like, if I'm at 0th index, now I'll run my loop from 1 to n minus 1. If I'm at the 1st position, I'll run my loop from 2 to n minus 1. It's like I'll run a nested loop. That's how it will go on. We will have the next equals to -1. That is why we are just initializing an integer next ij. Okay, by the way, this is not the, it's how I'm using a function, like how you are implementing a function. I guess you have studied about the functions. It's like, this is what we defined a function, and it's not our main. And in this function, we are passing two parameters. One is the integer array, and integer n is the length of the array. And here we will just print out what will be the next greater element. So you will be running a loop from I equals to 0 to I less than n. And your next will be probably -1. When you go from j equals to I plus 1, like, you will be always assessing from the I plus 1 till n. If you find in any element that is greater than array of I, you will just change this next variable, else you won't change it, and you will just write array of I and the next is n. But see, if you guys see this, it has a time complexity of order of n square, but we can also change it to when we can reduce the time complexity with the help of using the stacks. So anyone, how can we use stacks to find the next greater element? Okay, fine. Let's, okay, how you will go with the stacks, let's say. Let's say we have 4, and that was 5, then it was 2 and 25. As I know, I'll always start from the rightmost element, that is 25. I'll initialize my vector. I will having, let's say we are storing all these in a vector. So my last element, that is n minus 1, will be initialized as -1. Now what I will do, I'll push this in the stack, say 25. I have pushed it in the stack. Now move to the left element to it, that is 2. I see just what is in the top of the stack. The top of the stack here is 25, and as 25 is greater than 2, I'll write here 25. I'll get this element access from the top of the stack, and then I'll push 2 here. Then when I move to 5, now when you see the top of the stack, that is 2, 2 is less than 5. So what we will do, will probably pop the stack. And after that, we'll see the next element with the help of the top, that is 25. As 25 is greater than 5, we'll put here 25. And then you go to 4, it will be, okay, after going to 5, you will enter 5 here. And now when you move to 4, the topmost element here is 5, which is greater than 4, that, and you will enter with the help of the top. Does anyone have any doubt in this approach? Okay, let's go to one more example. Let's say if it was 27, 25. So the first, if you had a vector, you will always start from the rightmost element, as you will always initialize this to the -1. You will push your 25 to the stack. You move to the next element, that is 2. For 2, the top of the stack is 25, which is greater than 2. So you will enter here 25. After entering, you will push the element 2 to the stack, because you need to find the next greater element. When you come to 27, for 27, as 2 is less than 27, you will first of all pop this from the stack, because, and then you will move to the next element. So now 25, after popping, 25 is the topmost element of the stack, but since 25 is also less than 27, you will also pop 25 from the stack. And since the stack is empty now, you will, it means that for 27, there is no next graded element exist. So you will enter here -1, and you will push 27 to the stack. Then you will compare 4 with the 27, as 27 is greater than 4, then cause the next greater element for 4 is 27. So if you go to the approach, so here again we are using the functions that will return a vector long. Here long represents a long integer and the next largest element. So the parameters that you are passing are so called a vector array and an integer n, that's the size of the array. Always we are initializing the rightmost element to the -1, and we are declaring a stack with the long integer, and the name of the stack is S. So we will first of all push the array of n -1 as there, and from you will be starting from 25, you will be initializing to -1, and then you will be starting from this element. The same. Now you will always check while your stack is not empty, you will always pop it. And if your stack top is less than or equals to array of I, till then you will let it pop. Let's say if your stack becomes empty, you will stop popping it out. Or if your top is greater than array I, you will stop popping it out. So the next condition that you have to check, if your stack is empty, it means that there is no next created element for that ith element. So you will initialize p of I2 minus 1. Else you will write p of I2 s dot top, and you will push the array of I the next. After this, you will return. So with the help of the stacks, you are able to reduce the time complexity from order of n by order of n. So any doubts in this? I guess no doubts. So let's move to the next. That is queues. Okay, let's say you are probably standing in a queue for collecting the tickets. So, okay, as you know, this is a queue, and this person is at the front, and this person is at the back. Now, if you want, now if a new person is added, probably say where the person will be added. The person will be added always at the back, that is at the rearmost point. And the person will be removed from the queue only from the front, right? So this is how a queue works. The same case, we have this queue SGL, which works. What is actually a queue? It stores a list of items in which an item can be inserted at one end and you can remove it from probably the other end. Let's say here the elements are follow the FIFO principle, that is first in, first out. But as compared to stack that follow the principle last in, first out, the one which gets entered the last will be the first one to be out. But in queues, as the name suggests, the person or like the element that enters first will be the one to first out. So let's say this is your queue. So we always say this is from where the elements enter and this is from where the elements exist. So what are the operations we can support by the queue? That is, let's say you have a push X that will always push the element at the back of the queue. So let's say if this is a queue, this is your front element, and this is your rear element, that is a back element. So whenever you will insert the queue, it will always get inserted at the back. That is after 10. So after insert, your queue will look like this. Your front element will remain the same, that is 50, but your back element will change as a new element has been added, that is 60. If you call a function pop, that is you want to remove the element. As we know, you can remove the element only at the front. So when you will call the function pop, it will remove the front element, that is 50. So after calling the function, your front element will change to 40 as 50 has been removed from the queue, but the real element will remain the same because deletion is always done from the front. So like what are the other operations that are supported by queue? Let's say when you call a function front, it returns the element at the front of the queue. When you call a function back, it returns the element which is at the back of the queue, like that is the last element inserted. With the help of size, you will return the size of the queue, and empty will check whether the queue is empty and it will return a Boolean value. So if you go through this, let's say if before deletion, if it asks you what was your front element, you will say 50, the back element will be 60, the size will be 6. And if you call the function empty, it will be false because your queue is not empty. But after calling the pop function, the front element will be changed to 40, and but the back element will remain 60. And of course, the size will change itself. And similar to it, these all operations are all executed in order one of time, that is constant time. Okay. So now, as we have studied about the stacks and the queues, we know that in stack, we can either add at the end or you can either add, like as in stacks, you know, you will add at the top or you can remove from the top. But in the queues, you can remove at one end and you can add at the other end. But what if you want to add and remove from both the ends? So that is how the dequeues works. So it is like doubly ended queue. While stacks and queues allow for the constant time insertion and deletion only at a particular end, dequeues provide a constant time insertion and you can delete at the both ends. Let's say this is your queue, this is your front and this is your rear back. If assume if it was only a queue, then you can add the element. You cannot add the element at the front. You can only remove the element from front, and you cannot remove the element from the rear if it was a queue. But with the help of the deque, you can add and remove from both of the ends. So that's how it works. So if you see what are the operations that you can support by a deque, so it is first of all push the front X. So what does, as you know, what is pushing? Pushing, it means you are adding the element. For if you are adding the element at the front, you will call the push front X. And if you add the element at the back, you will call the push backing. And pop front will remove the element at the front of the DQ, and pop back will remove the element at the back of the DQ. Let's say if I call push front 80, then it will add the element 80 at the front. And if I call the pop front, it will always pop 70. If I call the pop back, it will pop out. It will remove the element 10 from the back. And yeah, front will always return, which is the element at the top of the queue, and back returns the element that is the back of the DQ. Size, it will always returns the size of the DQ. And to check a function whether your DQ is empty or not, it will return a Boolean value that is the true or false. And as you know, the time complexity of all this operation is constant, that is odd one. Okay, let's say comes to the queue reversal. Say you have been given a queue and you want to reverse a queue. As you know, it will be easy though, but still. Let's say you have been a given integer queue. Let's say, okay, let's make this as consider this as let's consider this as front. So your 1, 2, 3, 7. Now you want to reverse the queue. It means that your queue should be in this way. 7, 5, 4, 1. Like your front element is 1, but after reversal it should be 7. So how you can do it? You will very easy to do it with the help of the stacks. So in this case, what are the functions that are we gonna use? Let's say you will always use, let's say you will create a stack. You will store it in a stack. So it will go like this 1, 5, and 7. And when you pop from the stack, it will be again the 7, 5. So what are we doing? We will be initializing a stack that will be of integer data type, and you will what you will do, you will push in the stack. That is, let's say if you had this was the front end, it started from here 1, 2, 3, 4, 5, 7. So the front you will always first of all push it in the stack. Then you will, after pushing it, as you know, you can only access the topmost element of the queue. So you need to also call the pop in the queue so that it will, after calling out 1, it will remove the first element. After pushing the 2, you will call the pop, which will remove the second element. Then again, the top element will be 3. And so on. So you will start dot push will be q dot front, and you will, after every time pushing an element, you will pop the queue, else you won't be able to move out of this loop where you will run into an infinite loop. And after this, as we have the stack, as stack will always omit the one which was added last. It means your last element in the queue will now become the first element in the queue. And after this, you will again call the stack.pop. And this is how you will reverse a queue with the help of the stack. Okay. Does anyone have any doubt regarding anything? Like, I guess if there are doubts, then the next person can take off. Maybe. I guess Shashank, you can take over. I guess there are no doubts.
I think Shruthi will go, like sets and multisets will be fine.
Okay, fine. That's fine.
So am I audible? Could someone confirm?
Yeah,
Yeah,
Shruthi.
you're audible.
Okay, thank you. So hello everyone. I'm Shruthi. I'm one of the coordinators in the programming club. So I'll be taking sets and multisets. Just a moment. So is my screen visible?
Yep, it's visible.
All right. So sets sets are basically like containers. They're like STL containers, and they store unique elements. So one special property about sets is that they store unique elements and they are stored in a sorted order. So even if we try adding an element which is already present in a set, it will not get more than once. So what the basic operations that we can do with set is basically inserting an element and removing an element. We cannot modify it like the way we do in arrays or vectors. We can insert an element and delete if we require. So the position, it will keep on dynamically changing because the set needs to maintain the sorted order. Usually it's ascending, but we can change it as per our requirement as well. So sets are implemented using binary trees. So how do we declare a set? We write set followed by the data type of the element that we want to store, followed by the name of the set. So for example, if I want to store a set of integers, I will just write set angular brackets integer, then the name of the set that I want, set of int. Similarly, I can have a set of strings. You can also have set of pairs, for example, pair of int comma string, whatever we want. We can also have a set of sets. So this is one thing that we should note. We can have a container containing a container which is a container itself. So as I said, it is usually stored in a ascending order, but we can store in descending order as well. So we can use the word greater. So we can write set data type comma greater. So this data type will be the same data type as that we want to store and followed by the name. For example, if we want to store the elements in a descending order, like a set of integers stored in a descending order, you will just write set int comma greater int followed by the name of the set, that is S1. So is there any doubts as of now? Okay. So as I said, the set stores all the elements in ascending order or any sorted order. We should know how to access them. So they are accessed using iterators. So iterators are similar to pointers that point to the elements stored in the container. So sets and multisets have bidirectional iterators, while vectors have random access ones. So we will look at what they are. So random access iterators are the iterators that we saw in vectors. So there we can increase the iterator by any integer, for example, 1 or 2, to move by 1 or 2 elements or 3 or 4 or whatever be the number of elements that we want to move through. We can use plus plus to increment by 1 or minus equivalent to go back, and similarly use any integer to increase by that many number. We can also compare iterators and vectors using lesser than or equivalent to less than greater than not equivalent to equals equals. But we need to note that the iterators and sets are bidirectional. So they can only be incremented in steps of 1, and that too only plus plus and minus minus to go forward and backward. We cannot use plus equals 1. So it will the compiler will throw an error if you use plus equals 1, though you want to mean that you can increase by 1. Also, we cannot use lesser than greater than comparison for bidirectional iterators. We can just use equals equals or not equals. So is there any doubt in this? Please feel free to ask, because this iterator is quite different from what we've seen in vectors. All right then. So we will look at some basic functions. So I will just show them. So I've declared a set S of integers. I've used a function called insert to insert the elements in the set. So here I've inserted some random values in some random order. So let me begin by printing. Yeah. Fine, I will.
We can see only your slides. I think you have to change the window.
Oh, is it? Okay. Thank you. So is my IDE visible to everyone?
Yeah, yeah.
Okay, thank you. Yeah. So here I've inserted some random values here. So 1, 4, 3, 3, 5 in a random order. So I'm using s.begin here. So begin, it returns the iterator pointing to the first element. So and end, it points to the element to the right of the last element of the set. So that is the reason why I'm using minus minus here, because it is not s.end is not the last element. It points to the right of the last element. So we can see here, I got 1 for the dereferencing of s.begin and 5 for minus minus of s.end. Similarly, rbegin returns the reverse iterator, which points to the rightmost element of the set. So it is like we're traversing the set from right to left, and our end returns the element to the left of the first element. That is basically, to the left of the leftmost element. So I'm using minus minus here. So we can see here that rbegin gave 5. I've used plus plus rbegin. So I'm going from right to left here. So we can see we got 4 here. And minus minus r dot end gives 1 here, which is basically we're going right here. So I hope you're getting the difference between rbegin and begin. So is there any doubt? Okay. So size function, it returns the number of elements present in the set. And max size, it returns the maximum number of elements that a set can store. So this is, okay, fine. Let me compile this to show the difference. Yeah. So s dot size, it gave me 4 here. I have 4 elements. Note that it's giving 4, though I inserted 3 twice here. It's 1, 3, 4, and 5. And max size for S is returning me this number. And I've declared another set of sets here, set of ends. So here s1 dot max size is returning me this number. So we can see that these two numbers are different. So the maximum number of elements that a set can store depends upon the data type of the element that we want to store. Is that clear? Okay. So how do we use iterators in C++? So we'll write set followed by the data type of the element, followed by double colons, and the iterator. We need to write the word iterator followed by the iterator name. So instead of writing such a big line, we can use the word auto. So auto is a keyword which is used to which automatically assigns the data type to a variable based on the value that we're trying to assign here. So if we want to use auto for iterators, we can just write auto followed by the iterator name and then say set.begin or set.end or rbegin. So Say I want to print all the elements in the given set. So what I've done here is auto equals auto IT equals s dot begin, and here I'm using s dot end not equals. So please note that, and I'm using IT plus plus to increment by 1. So here I've gotten 1, 3, 4, and 5. So is there any doubt as of now? Okay. So let us look at some more functions which we can use in sets. So I've already mentioned insert, which basically inserts the element in a set. So let us look at, suppose you want to remove an element from a set. Say I want to remove 3. So I will just use s dot erase followed by the number that I want to remove here. Yeah. So one more thing, I can use auto IT followed by colon in S. So basically, IT is all the IT will go through all the elements present in S. It's similar to for I in range or something like that. So where it goes through all the elements present in the set. So we can see here we got 1, 4, and 5. Say we want to remove an element, we want to find the iterator pointing to an element. So we can use the find function. So I want to find whether I want to find the iterator for 4. So I will write auto IT. So basically an iterator here. So when I dereference it, I get 4 here. Also, like in many of the questions, you might be we want to find out whether a set is empty or not. So in that we can use s.empty, or basically the name of the set dot empty. So this returns a Boolean value of true if the set is empty. Otherwise, it returns false. So my set here is not empty, so I'm getting not empty here. Is it clear? And if I want to empty a set, I can use s.clear. So now my set is emptied, so s.empty is returning true. So is there any doubt in sets as of now? Why not star IT in 33 line? Okay, yeah. So in line 33, IT is not the iterator pointing to S. It basically traverses all the elements. It goes through all the elements in S. So IT is the element, it's not the iterator. Is that clear? Tanmay? If you're still having a doubt, you can unmute and ask. Okay. So are there any more doubts? Okay. So now let's discuss the time complexity associated with sets. So for accessing an element and modifying an element in vectors or arrays, we will directly use indices and we'll get O of 1. Whereas in sets, we need to find it. So for that, it takes log n time. Say we want to search for an element, we can use binary search as we learned earlier. So we will get we can have a best of O log n. In sets, we have O of log n as well because of the binary tree implementation. Insertion, we have O of n, and deletion also O of n in vectors. Whereas in binary search tree implementation, that is basically our set, we'll get log n time. So let us solve a problem now. So you remove smallest. You are given the array A consisting of n greater than 0 integers, positive integers. In one move, you can choose to indice as I and j, where I and j are different, such that the absolute difference between AI and AJ is no more than 1. Remove the smallest of these two elements. If the two elements are equal, remove any one of them, but exactly one. Your task is to find out if it is possible to obtain the array consisting of exactly one element using several moves. So we're allowed to make as many moves as we want. So you have to answer T independent cases. All right. So are there any ideas or that you can think of? Okay. So I'll probably give 1-2 minutes for you guys to think. You can put in your ideas in the chat or unmute and speak. Are there any doubts in this question, first of all? Okay, so I think I'll go ahead with solving the problem. So we are given, let us take one example and solve. 1, 2, 2. Okay, we have 1, 2, and 2. So say we choose 2 and 2. So I is 2 here, and we have I equals 1 here, 2 here, and 3. So if I choose I is 2 and j as 3, so 2 and 2 are of the same value. So say I delete this, exactly 1. Now I'm left with 1 and 2. So I choose, so out of these, 1 is the least, so 1 is deleted. So now I'm left with one element. So we can reach one element in this array. Now let us solve for 5, 5, and 5. So 5, 5, 5, 5. So I choose these two as a pair. I delete this. Then I choose these two as a pair. Delete this. Then I choose these two as a pair. Delete this. So I finally end up with one element. Now say I do 1, 3, 4, and 4. So here I can just choose 4 and 4. So I'll delete 1. And we land up with 3 elements. So I'm supposed to return no for this. So are there any approaches that you can think now, given that I've dry run this? All right. So what can we like infer from this example? Suppose we have like any number of occurrences of an element of one single value, say 5. I have 4 occurrences of 5. I can ultimately reduce it to one occurrence. So say you have y some x many number of times. By following by doing x minus 1 such operations, I can finally end up with one occurrence of y. Now, in order to remove y, I need y plus 1 along with it. So is that clear? So in order for me to remove an element, remove a value from the array, I need y plus 1. So here, the number of occurrences of a given value is of no value because I can ultimately form that, like do many operations and end up with one occurrence of that element. Now, in order to remove an element, I need y plus 1. So what can we do here? So what we don't need to care about the number of occurrences here. So what can I do here? I can just create a set containing the elements in a sorted order. So if I use a set, the order is taken care of and multiple occurrences also is taken care of. All I need to do is check whether the elements differ by 1. So say in this 1 to 2 example, so when I store the elements in this set, I have 1 and 2. I just need to check if the consecutive elements differ by 1 or not. So in 1, 3, 4 or 4 and 4, so the set will be stored as 1, 3, 4. So here 1 is the difference, but here we have 2 as a difference. So we cannot have this case. Similarly, if we have just one element, one value repeated many number of times, as in here, the set will just have one element, which is 5. So which is correct. So is there any doubt or any questions regarding the approach to solve this problem? Okay. At first, we can look for equal elements and then elements with difference one. Correct, absolutely. All right. Are there any more doubts? I'm sorry, I did not look at the chat. Right. So let's look into the code. So I'm running a while loop t number of times, which is the test case here. So I'm declaring a set s of integers. So I'm inputting the value of n, and I'm inserting the values of the given array in the set. So I'm using another variable f here as a flag. I'll explain later why I'm using f. So first of all, I'm checking if the set is of size greater than 1. So that then I'll have to iterate and then find out if the consecutive elements differ by 1 or not. So if the size is equals 1, then f is 0 and I will print out yes directly. If the size is greater than 1, I will have to traverse the elements. So what I'm doing here, auto it equals plus plus is dot begin. So I'm starting initializing it with the second element here. And I'm checking whether, and the loop ends when it reaches s dot end. So it will go to the last element. So it plus plus increasing by 1. So I'm using another iterator here, it2, which points to the element to the left of it. So I'm using star to dereference here. So star it minus star it2 is basically right element minus the left element. Now this will always be positive because the set stores the elements in a sorted manner. So if it is not equals 1, I'm changing this flag to 1, and I'm directly outputting no, and I'm breaking out of the loop because it's we don't need to check further. So if this loop is executed properly, I mean, if it reaches s dot n, means that the consecutive elements differ by 1 and are set and we have to output yes. So I've used f equals 0, see out yes. So is there any doubt in any of the parts? Okay. So let me try submitting the code. Got accepted now. So is there any doubt? If there's any part that I need to explain again, please feel free to ask me. Okay. Can we use star IT minus star IT minus 1 in line 25? Yeah, this is exactly what I was saying, that you cannot use minus in bidirectional iterators. We are strictly allowed to use only minus minus or plus plus. We cannot use integers like this. So if you want, I'll just try that and let's see what happens. So yeah, see, I think it's not allowing me to do so already. Okay, there's a parentheses mistake. Yeah. Yeah, so I think, yeah, we cannot use minus 1 here. Is that fine? Tanmay? Is it clear for you? Okay. All right then. So are there any other questions in sets? Or in the problem that I solved? All right then. The rest 3 problems are based on sorting and unique element property. So you can check these problems later when I share the slides. All right then. So can we move on to multisets now? Or are there any more concerns? All right. So multisets are very similar to sets. It's just that we can store multiple elements of the same value. So here, as we saw in 1, 3, 3, 4, and 5 that I tried here, you can have multiple elements. And like sets, we can have, okay, I'll just right here. So the syntax for multiset is just multiset followed by the data type, just as we saw in set. It's just that we need to use the word multiset instead of set, all this way. So insert, the same function remains where we can just insert the values. So I've inserted multiple instances of the same value. So just so here, same thing, I'm using ms.begin, like the way I use s.begin here. So ms is just the name of the multiset that I'm using here. So this points to the begin is basically the first iterator to the first element, and ms.end is the iterator to the right of the last element. So this is exactly same. Now let us see what are the elements printed. So we can see here we have 1, 1, 2, 2, 3, 3, and 4. So we can see that there are the values are stored in a sorted manner, and we can have multiple occurrences of the same value. So is that very clear? Or are there any doubts in multisets? Okay. Right. So we can use a function called arrays. Here we need to be very careful because when I use ms.arrays of a particular value, all the instances of that value is deleted. So if I run this program after using arrays, you can see that 3 was there twice in ms, but now it is not there. So dot arrays with value in the parentheses removes all the occurrences in the multiset. Say you want to remove only one occurrence of the multiset. So what am I doing here? So ms.arrays, ms.find. So find, it basically returns the iterator pointing to the first occurrence of that particular value. So now let me run the program. So we can see here 1, 1, 2, 3, 3, 4. So 2 is printed only once here. So is it very clear? So if I want to use array, if you want to erase only once a particular element, you have to put the iterator inside. So I could have done it by initializing another iterator. So auto it equals ms.find of 2, and I can put the iterator inside here. The same is executed. So is there any doubt in arrays here? Right, and I think I've explained find as well. So count is a function. It returns the number of occurrences of a given value. So so we have 1 twice here. So I've gotten 2. So are there any doubts in the functions here? It's very similar to sets. It's just that there are multiple instances of the elements. All right. So clear function, as we saw in sets, it empty is the multiset, and empty it's the same. All right, then we'll solve a problem. So are there any doubts in functions, or can I proceed with the problem? Okay. So our monk loves candy. While taking a stroll in the park, he stumbled upon n bags with candies. The ith of these bags contain AI candies. He picks up a bag, eats all the candies in it, and drops it on the ground. But as soon as he drops the bag, the number of candies in the bag increases magically. Say the bag that used to contain X before eating now contains X by 2 candies, parentheses X, where is the greatest integer function that we know. So basically floor division or GIF function that we know. Amazed by the magical spell, Monk can now have a lot more candies, but he has to return home in K minutes. In a single minute, Monk can consume all the candies in a single bag, regardless of the number of candies in it. Find the maximum number of candies that Monk can consume. So we are given t test cases followed by n and k. N is the number of bags and k is the number of minutes. Second line of test case contains n. It's given the number of candies in n bags. So what we are supposed to do? We are supposed to find the number of maximum candies that Monk can consume. So I'll give you some time to think, and if there are any questions on the problem, I'll answer them. Okay. So I'll give you guys 2 minutes to think of an approach. Are there any ideas or any questions regarding the problem? Yes, Tanmay, you can unmute, I think.
If we consider the given example,
Mm-hmm.
so in first bag there are two candies. So means for 3 minutes we can calculate that how many candies would be there in that bag after 3 minutes.
Okay, Alan, could you like
Means
tell?
if we take two, so in first minute there were two, in second minute it would be one, and in third minute there would be zero candies.
Correct.
And so like this for each bag, and then we will store all this data into a multiset.
Hmm.
And then if over here it is 3 minutes, so we will take the sum of the last three elements of that multiset.
Okay.
And that's
Uh,
the answer.
okay, so say I have 14 here instead of 7. So what would your program do? 2, 1, 14, 4, and 2.
Okay, so
So
for 2 it would be 2, 1, 0.
no, we have totally 3 minutes only. So I
Yes,
think I'll
yes.
explain the. Yeah, go ahead.
So for first bag, in first minute there are two candies. So he would finish them up, and at second minute there would be one candy.
Okay.
And in third minute there would be zero candies.
Correct. That's only if he chooses to, right?
Yes. For one it would be 1, 0, 0.
Oh no, I think you misinterpreted the question. At 1 minute, he's allowed to consume only one bag. So the first bag, if he consumes, he'll get only 2 candies in the first minute. In the
Yes.
second bag, he'll get only 1 candy. But if he chooses the third bag, he'll be able to consume 14 candies in 1 minute. So 14
Yes.
will be a better approach to choose, right?
Yes, yes, that's definitely. But means I've taken a general idea that I would do it for all bags and then find the maximum.
Okay, but in that case, uh, so you're saying all 3 minutes I will consume the same bag.
Yes.
Okay. So say in 21742. Now, if I say here, I will consume 210, so maximum 3 candies consumed.
Yes.
Here, 1 candy consumed. So here, 7 plus 3 plus 1.
No, not like that.
Hmm.
Means I would means for example, if we take two, so I would write 2, 1, 0 in a line. For one, I would write 1, 0, 0.
Hmm.
For 7, 7, 3, 1.
Okay.
For
Hold on.
4, 4, 2, 1.
For this, 4, 2, 1. Okay.
And for 2
And
again, 2, 1, 0.
okay, then.
Now I would take, I have this data, I would take the maximum in all this data, maximum 3, because I have
Hmm.
only 3 minutes.
Oh, okay. So you're saying for each minute, I'll take the maximum over here. Is that what you're
No,
saying?
so for 7 we have no 7, 3, 1. So maximum in whole data is 7.
Okay.
So 7 would definitely be my choice.
2, 1, 0. Okay, so you're taking 7 here. Okay, all right.
Then 4, because number less than 7 is 4, just less than 7. And then 3.
Hmm.
And that sum would be my answer.
Right. I think you're like, but then your implementation would be kind of different, I think. But I think you're getting the essence of the problem. But where will you store these elements again?
I can store them in a multiset.
These 3 elements.
No, all elements.
Okay. So
All the
instead of
15
writing
elements.
731, so I can just proceed minute by minute, right?
That's also fine. Yes.
Yeah. So what I'll do there, I will just take 7 in the first minute, and then I'll replace it by 3 after I add 7 to a counter of whatever I want to count, counter of candies, right?
Yes. Yes.
All right. So is there anyone else who wants to? We have to make largest element to n by 2. We have to convert largest number to n by 2, and then we have to find the largest among it and continue k times. Yes, that's absolutely right. That's exactly what we're going to do here. So is the approach clear, or I'll explain it again? Yeah, I think I'll explain it again. Right. So as one of our friend told, we will keep our array in a sorted manner. So 1, 2, 2, 4, and 7. So here we are taking the largest element. We are using the greedy approach here. So please note that, like, at every instant we are taking the largest element. So 7. So for our counter, I will take 7 in the first minute. Now I will change it to 3. Now the greatest element changes to 4. So now I'll take 4 in the second minute. So 7 plus 4. And this will change to 2. Now the greatest element here in our multiset is 3. So I will take 3 here. And that many number, and if there are further minutes, I will continue the same iteration that many number of times. So at every instant, we are choosing the greatest element. So we are using the greedy approach that we learned earlier. So that will give us the maximum number of candies that monk can have. So let me try running for the, like, try running this. So 1, 1, 2 for the second test case. 2, oops, 3, 3, 3, and 5, 5, and 5. So here the maximum element is 5. So I'll take any one of them. Okay, I took one of them. Make it to 2. Now the maximum becomes 5 here again. So I'll take another 5. And this becomes 2. Here the maximum is 5 again. So this will become 2. And I will take here 2. Since we are asked only for 3 minutes, 5, 5, and 5 makes it 15. So are there any doubts in this approach or the way that we're going to solve this problem? Okay. All right, then I'll go to the code. So here I'm declaring a multiset MS. Here, as I mentioned earlier, I'm using greater to store the elements in the descending order. So now I don't need to do minus minus. Otherwise, I can just do minus minus ms dot n. To make it clearer, I used descending order here. So I'm inputting n and k, the number of elements, and I'm inserting the values inside ms here. So I'm using count, which is basically going to count the number of candies that monk can have. So here I'm running this loop k number of times. So what I'm doing, so I'm adding ms star of ms dot begin. This will give me the largest, I'm adding the largest element of the multiset here. So, and then I'm inserting x by 2 here. So star of ms dot begin by 2 here. So this will take it, as we know in C++, just direct by 2 will give us the GIF itself. And now I need to erase the value. Now I'm not doing star of ms dot begin here because that will release all the occurrences of the highest value, which we do not want here. So I'm passing in the iterator itself inside. So is that very clear that why I'm not using star of ms dot begin and not why I'm not using star of ms dot begin and using ms dot begin here? Okay, if you have any doubt, you can unmute itself. That will be better. All right. So at the end, after the end of k minutes, I repeat the same k number of times, and then I'm outputting count. Is there any doubt in this program? Any of the lines here? Did everyone understand why I didn't use star here? Okay. So let me try submitting this code. So it is accepted. So is there any doubt anywhere? So one thing that I would like to appreciate like here is that we could have tried to solve this using vectors or arrays, but here we multiset is saving us the effort of maintaining the maintaining the order of the elements here at every point. So like we need not worry about sorting the array again and again or the vector again and again here. And here all this insertion addition is happening in O of one time. So making it k, the complexity k here. So if I had to use a vector or something, I would have to use I would have n log n complexity of sorting the array again and again, making it k times n log n. So here we can see that multiset is just saving us all the time and effort. We need not even worry about the order at any point of time. So is that like I hope you're able to like appreciate the fact that how multiset is just making a problem much easier. And while we have to sort every time if you're using a vector or something, of course this can be solved using vector, but I hope you're able to like understand the difference. So is there any doubt in the problem that I solved? Okay. The other problem is also something similar to this, and I leave it as an exercise. So if there aren't any doubts, then I think the next person can proceed.
Yeah, sure. Is my screen visible?
Oh yeah.
Okay, hello guys, I'm Shashank. Today I'll be going through the maps and multi-maps. Okay, let's get started. Okay, first maps. Maps are morely like sets only. In the sense, they store data in the ordered form. They remove repeated values. Here also, they will store in the ascending order, and like we can change it to descending as our wish. But the default thing is they'll arrange the elements in ascending order. Maps are associative containers. Elements are stored as key value pair. It's like storing pairs in sets kind of thing. We'll go through that. Okay. Each element will contain two values. One is key value and one is map value. And here you cannot have like a single key can map to only one map value, not like a single key can map to multiple map values. That is one difference between maps and multi maps. You'll understand that few minutes after. Here the computer stores map in the form of balanced binary tree, similar to the sets. Yeah. The thing is, it will help in the like for search functions and all. The time complexity will be logarithmic time because like O of log n because of this binary search tree. Okay, now we will move to declaration of map. How to declare map and then data type 1, data type 2, and then the map variable name. here the data types can be int, string, char, bool, etc. One thing to note is there can be even STL containers such as vector, set, or even maps. Here data type 1 corresponds to the data type of the key, and the data type 2 corresponds to the data type of the value. And then say example, for example, say map int, this is the int is the data type of key, and the string is the data type of value pair. So emp is the variable name, initializes an empty map which can store pairs of the form in string. Example, say 5 and 5 in words. A few examples how to declare map int, and like this is like key is of data type int, and also the value is also of data type int. And as I told before, we can declare STL containers as data types as well, say string and vector int and int, and like to store them in descending order, we can declare the map this way. And then the data type should be mentioned in here. Let me just show how to code. Can you see my code? Like VS Code I have opened.
Yes, Shashank, it's visible.
Yeah. Here, first, like I declared a map which the key has data type int and the value has data type int, and a few other examples: string, char, charbel, and like STL containers like vector and string. Yeah, it's clear, right? Any doubts? Okay, I'll continue then. Inserting into a map, like they use dot insert function. Similarly, as in sets, here also we have like map dot insert function. There are different ways to insert in maps. Say like these are like different methods. I'll go through them one by one. Here, say map name dot, the syntax is insert and key and value. You can just pass this and like they'll get inserted. This function returns an iterator to the new element of the container. And if the key is already present, then it will not insert anything. Like it will not insert the value key value pair you pass in. Yeah, the other way to like insert is dot emplace key value. This also does the same job. And like syntax, different syntaxes as I told. Map name key equals to value. This will also insert the key value pair into the map. And the time complexity for both is O of log n. The difference between these two is here you can rewrite in the second syntax, and the first syntax you cannot rewrite. Like say initially you have like 2, 3 pair, and now like if you code like map mp say 2 equals to 5, then like in previously 2, 3, right? Now like it will rewrite, it will become 2, 5. But in this case it will not do anything. It will just remain 2, 3. Let me just show. Say like mp.insert make pair. This is also one more thing, like how we can pass in. I have inserted 1, 10. I have also inserted 2, 20. And say like if I wait just before, like I'll go through all of this. MP of 3, like I initialized like I inserted 3, 25, also 4, 40. Let me just like these are things how we insert. Let me just run through them. Let's check. You can see, right, like first one is mapped to 10 and 2 is mapped to 20 and then 3 is mapped to 25 and 4 is to 40. Say like if I uncomment this, I have to show that like it will not do anything. So let's just check. See, like even if I insert 2,25, it does nothing. Okay, and now if I'll uncomment this, just to see that it will rewrite in this case. Now you can see that 3 is mapped to 30, right? In this case, you can rewrite, but in this case, it does nothing, even if you pass the like same key value, which is already there. Okay, few other ways to insert. You can insert by passing iterator. What it does is it will start searching to insert from this iterator. Let me just show in the slides. Yeah, this function, this is usual. Iterator position does not specify the position where the insertion is to be done. What it does is it points to a position from where the searching operation for insertion is to be started. It is just to reduce the time complexity. Here you can see, right? Say I declare an iterator and it points to the, say, where the element is a, like I'll tell about this function later. It is similar to sets. Now it will start searching from this and then it will insert somewhere. It is just to reduce the time complexity. Yeah, different ways to insert, that's all. If you want to copy some values from another map which already has some elements, then you can use this method, say mp1, which already like I assigned few values to it. And then you declared another map nq1, and like if you want to copy the elements in mp1 to nq1, what you can do is this. Say I declare an iterator which points to the begin like a of mp1, and then like I did itr plus plus. Here we can't use plus equals to 3 because like here also like bidirectional iterator same as say. And now what I'll do is it will insert elements from the iterator position 1 till just before the position 2. So I took till the end, and then what it does is it will insert A1, B2, and then C3. Let's just see in the VS Code. Same code. I'm printing the elements of NQ1 now. So you can see, right, like A1, B2, C3 got inserted into NQ1. This is like copying elements from another map. Yeah, any doubts still now? Difference between key and value. It is like key is the first element, first thing in the pair, and value is the thing second of that pair. Key value pairs, that's all, like kind of you have learned about pairs in the previous session, right? So that, like say pair x, x dot first is the key and x dot second is the value. Is it fine? You can unmute and ask, like I may not see the message instantaneously. Okay, how to access the element from a map? Say map name, MP, and key. What it gives is the value stored in this key value pair. It is much similar to arrays, but the difference here is the key need not be integer like in arrays. Here it can be string, char, and depending on the variable you declare for the data type you declare for while the map is initialized. Example, map in string MP, say like 7 and Dhoni, and when you output MP of 7, it outputs Dhoni here. Example for that. Yeah. Oh, oops. Yeah, like just check here we have inserted 2,20 and 2,25 does nothing. So I'll just comment this. Let's see the output here. 2 is mapped to 20. So MP2 is MP of 2 is 20. Yeah, next, how to print the elements of a map. We'll just do it here. Similar to sets, here also X will go through all the elements of the map and then it's not the iterator. Similarly, someone has asked the dot before. So you can see, right? Just one is okay. X dot first. 1 is mapped to 10 and 2 is mapped to 20. 3 is mapped to 30 and 4 is mapped to 40 and 5 is mapped to 50. And another method to print is using iterator. We will see. Yeah, here we declare an iterator. Auto will is intelligent enough to understand that it is an iterator. Let's say begin. I'll just tell about that in few minutes. Till the end. What end does this? It will return a pointer just after the last element of the map. Till then, we will increment this and we'll try printing. Yeah, see, you can see, right? Like 1 is mapped to 10, 2 is mapped to 20, and so on. Any doubts? I'll continue. Like you can do a problem before we move. Like there are few functions to be covered. We don't use them in this problem, so just I'll go through that. Okay, I'll read the question and give you some time to think. Harry Potter is on a mission to destroy, whose Horcruxes? It is Voldemort's. The first Horcrux that he encountered in the Chamber of Secrets is Tom Riddle's diary. The diary was with Ginny, and it forced her to open the Chamber of Secrets. Harry wants to know the different people who had ever possessed the diary to make sure they are not under its influence. This is the story, and here's the names of n people who possess the diary in order. You need to tell for each person if he or she possessed the diary at some point before or not. Formally, for a name, SI in the ith line, output S is without quotes. Okay. If there exists a J such that SI equals to SJ, otherwise output no. Yeah, you can think of this. I'll just keep it this way. I'll give you 2 minutes and then we can discuss. You can write your ideas in the chat or you can unmute and tell. You can see the sample input and output here. Any ideas? You can put it in the chat and you can unmute. Okay, I think I'll just explain the question once. What we have to check is like here Tom is like coming for the first time and Lucius is also coming for the first time. Ginny is also first time. Harry is also first time. And Ginny came like second time. So here we have to output S. And Harry also is like second time, right? So here also we have to output S. And in other cases we have to output no. Here like Harry is for the first time. So like I'll just give the numbering, say like 0 for the first time, like, and 1 for the second time. Like he came second. So like Luna is for the first time, so I'll give 0. Ron for the first time, so 0. Hagrid for the first time, so 0. Luna for the second time, so 1. So what we have to do is every time 0 comes, we have to output no. If it is 1, if it is like greater than 0, then we output S. I'll show the code for this. So like T is the number of names, and I'll take input T, and then what it is like take declare a map string as the data type of key, and like int as the value. Int is the data type of value, and I'll take the names of each person. Say it's like declare a string and take the string input, and like initially all those int will be 0. Now if I access like if MP of S is 0, then like it is coming for the first time. Like cause I'll increment after every name. So like if it is 0, then it is coming for the first time. If it is 1, it is coming from like it was already there. So I'll output S further. Did you get any doubts? Yeah. Rutvik, your approach is absolutely correct. That is what I have also done. Yeah. Okay, I'll just submit. Let's just check if it gets sent. Okay. I have submitted the same. Oh, 1 second. Like I have submitted the same code, so it is just showing like that. I got accepted. Okay. Any doubts in this question or like previously discussed thing? I'll take it as non continue. How to erase elements from a map. There are different approaches for this, and I'll just go through them quickly. These are not very important in CP point of view, but like you should know these functions exist, so like it might be of some help while solving problems. How to erase this key? Like the syntax is mp.erase. You'll pass the key which you want to erase, and like it will get erased. This will take key as an argument. What it returns is 1 if the key is present, and it will return 0 if not. mp.array is 7. Like if it is string, the key is string, then you can write this way as well. Okay, second method. You can also pass the iterator corresponding to the element, and the element will get erased. It will take iterator as the argument and erases the pair pointed by this iterator. Here, no value is written. Time complexity is log n. Here, if you want to like, if the key is of data type character, then you can write like this too. You can, if you want to erase the first element, then you can write this way, just to illustrate how you can write like this function. You can also erase the set of elements, like say you have to pass two iterators, start iterator and end iterator. What it does is it will erase the elements in this range, like starting till the just before element of the end iterator. Here also no value is returned, and the time complexity is log n plus distance of start iterator and end iterator. Why this is like log n is to go to the starting iterator and then to erase all the elements from start to end iterator, this thing. Like yeah, if you want to clear all the elements of the array, you can just you can also, there are other way to like erase all the elements. This is one approach. It will start from begin, and then it will end is like it points to element just after the last element of the map. So like it will clear all the elements. If you want to like erase it is equivalent to the previous function. It just erases the element which is pointed by this iterator itr. Okay, I'll just show them one. Accessing we have done, erasing, yeah. Now, like I'm erasing the 4,40 pair. See, yeah, you can see, right? Like 4,40 is not there. Yeah, I declared like, okay, this is for the next function, will come. Yeah, inside we have discussed, and also arrays we have discussed. So this is like just keeping all the important functions at one place. Begin is returns an iterator to the first element of the map, and the time complexity is O of n, O of 1, just like one. Yeah, how, like I declare it as auto itr np.begin, and the end is like returns an iterator to the theoretical last element of the map. What it means is like in strings we have like slash n at the end of every string. Similarly, it's like pointing to the slash n of the string. It is like the element after the last element of the map. Okay, this is how you declare it. Okay, yeah, just to check. Yeah, just to see like what is the first element of the map. You can, yeah, 1 and 10 are the first elements. It does like it outputs that it is fine. For the end, I declared iterator as this points to the element next to the last element. So like I decremented it by 1, itr minus minus. And then like I'm checking the what are the key and value pair in the last element. It is 5 and 50, so it is fine, right? Any doubts? Okay. Okay, wait. Yeah. How to like if you want to find if a key is present in the map or not, like you can use this function. It returns an iterator to the element with the key value equals to the parameter first. If it does not exist, then like it will return the end iterator, and the time complexity is O of log n. Yeah, like if you want to check like if 15 is present in the elements of map, then you can use this. If you want to find the size of the map, this function, you can use this function. It returns the number of elements in the map. And okay. Hmm. Like this is same as finding like but it returns 1 if the key is present. It returns 0 if it is not. But like in multi maps, what it does is like we'll see there like this function of count in multi maps. Okay. Like in this code. Okay, one second. In this code, it will check like if 15 is present, then it will output 1. If it is not there, then it will output 0. Yeah, what clear does is it will clear all the elements. Like I have just cleared all the elements, so the now size of map will be 0. It will output 0. What dot empty does is it returns 1 if the map is empty, else it returns 0. Like if the size of map is 0, it will return 1. If it is not 0, it will return like 0. If it is empty, like it returns 1. That's all. I'll just quickly go through this. Okay. Begin and we have covered and like how to find an element. Just wait. Just I'll show all of them together. Okay. First we are finding if 3 is present. Okay. What it is. Yeah, it have outputted 3 comma 30. Like 3 is there in the map. So yeah. What is the size of the map? Size of the map is 5. Like we have 5 elements, 110, so on, like till 550. And like count 2 is there in the like element, so like it will return 1. And yeah, we have like just to check like after clear how the size of map changes. Before it is 5, and like I have used the clear function, and then now size is 0. Let's like and comment this. Okay. If map dot empty, like if like here it is not empty. Like I have commented this, so like it is not empty. So it have to output map has some elements. Now like if I use clear function here, it will output map is empty. So yeah, did you get the idea of all this? Any doubts? Okay, let's continue then. These are few other functions like upper bound of key. What it does is returns an iterator to the element of the map with key value strictly greater than like note this strictly greater than the parameter passed. If none exists, then it returns the end function like end. The time complexity is walk log n. How to like just check? Here like upper bound of 4, what it returns is the key value next to strictly greater than 4. Like in our things we have 5 and 50, right? So it will return like iterated to the 5 and 50 thing.
So na to mo na ni mo rana yo ni ra im jo yo go se ka ka sai bo. To big ye ba ko kai ba na yo sai go mo
I
e ji
think
go
someone
chikara bo
have
ka shi te. So na to mo na ni mo rana yo.
I have muted. Okay. What lower bound does is it returns an iterator to the element of the map with value greater than or equal to the parameter passed. It is like if you pass 4 and 4 is there in the elements of the map, it returns like 4 comma 40 like in our set of elements. Let's just check them. Any doubts in this? Meeting chat is muted. Okay. Yeah, let's just check. Oh, wait. What happened? Okay, I have cleared all the elements here. So that's the issue. I'll just comment this. You should see the value. Yeah. One second. Yeah, 5 comma 50 is there. Okay, it have outputted 5 comma 50 here. I haven't used end line. You must. Yeah, 5 comma 50 and 4 comma 40. Like lower bound returns the iterator which is greater than or equal to. So like 4 is there. So it will return 4 comma iterator pointing to the 4 the pair 4 comma 40. And the upper bound what it is like it will greater than strictly greater than, so like it will return a iterator which points to like 5 comma 50 element. Yeah, like these are the functions in maps and like miscellaneous functions you can just go through them. These are not very important. Okay, before we move into multi-maps, any doubts? Any doubt in maps? Like till now, you can ask. You can unmute and ask as well.
No doubts.
Okay. I'll go through multi-maps then. Multi-maps are like similar to like sets multiset. Here we have maps and multi-maps. One of the feature of map is like each key can be associated only to a single value. That is in case of maps. But in multi-maps, like there is no such rule. A single key can be associated with many values. As we have seen before, like if you have a say like element 2, 20, then we can't have like 2, 25, right? But in multi-maps, it is not the case. Like if you have 2, 20, then you can also have 2, 25. One more thing is like if you have 2, 20, then you can have 2, 20 again as well. Like two elements and each are same, like 2, 20, 2, 20. That is the thing with multi-maps. Unlike we have edited, we can edit the value key value pairs in map, but in case of multi-maps, we can't do that. Yeah, like maps, multi-maps are also like sorted in ascending order of keys by default. The functions discussed previously will are present for multi-maps as well. Yeah, the things to note, like the differences between and kind of things. In sorting map elements, when two elements have the same key value, we can observe that they are not sorted in ascending order of the corresponding values. Like say, initially you pass 2, 20, and also like after passing few more elements, and then again you pass 2, 15. The pairs will be stored as 2, 20, 2, 15 only, like not like 2, 15 and 2, 20. They were stored in the order you pass, like if the key value is same. But placed in the same address, they were inputted. Okay. Uh, yeah, same thing. Yeah, I told like I'll discuss the count function in multi-maps again. Here what it is like we can have multiple like 2, 20, 2, 25, right? Like if we write count of 2, then it returns 2. It will count the number of elements with the key in multi-map. One special thing to note here is, okay, I'll just move. Wait, 1 second. Yeah. In case of upper bound and lower bound functions, if there is no element within the range higher, in upper bound functions, it returns the iterator which points to the greater than or like strictly greater than or equal to or strictly greater than, right? If there is no such key greater than in the set of elements, then what it returns is what it returns is the iterator which has key equals to size of multimap, and the value of value corresponding to that pair is will be 0. We will just see in the code. Yeah, let's just see in VS Code. Okay, here I have inserted 1, 10, 2, 20. Here 4, 40 as well as 4, 45. Like all will get inserted. There is no such issue. Yeah. Let's just print all this. Yeah, see, you can see, right? Like 1 is mapped to 10, 2 is mapped to 20, 4 is mapped to 40, like 4 is 45. You can note this, right? Like I have passed 5, 50 twice. Like it will store both. In maps, that is not the case. It will just store 5, 50 once. Yeah. Okay, I'll comment this then. To note the like lower bounds of the function, lower bound function. Yes. What do you guys think? Like for 1, the lower bound should be 1, 10, and like for 1, they should be same. And for upper bound, 1 it should be 2, 20, and like for 4, like for 2, 4 comma 40, and the for 4 it should be 5 comma 50, and so on like that. Let's see a lower bound. Lower bounds, as I told, like they'll be same cause like we are checking for the elements in the map. So like the key value will be present, so greater than or equal to thing. So like yeah. Let's see upper bounds. You will see the difference there. Yeah, like for upper bound, 1 comma 10 returns like 2 comma 20 and 2 comma 20, 4 comma 40. One thing I forgot to tell is like if we check for the lower bound of 4 comma 45, then it returns 4 comma 40, because like it will just check the first key value and takes that like outputs that. I'll just show that for like for 5, like for 4 comma 40 it is like 5 comma 50, and 4 comma 45 also 5 comma 50. And as I told, as you have seen that it will return the, if it is not found higher than, like there is no element with key value greater than k, then it returns an iterator, key equals to size of map and value equals to 0. You can see that, right? Like key equals to 6 for this, and 0 is the like value is 0. Is it clear? Yeah, one more function I have to discuss in multi-maps is equal range. Dot equal range of pair. What this function does is it returns a pair of iterators, like iterator of pairs. The pair refers to the bounds of range that includes all the elements in the container which have an key equivalent to k. So like okay, let's just see. If there are no matches with key, then the range of returned is of length 0, with both iterators pointing to the first element that has a key considered to go after k. Okay, here we are finding, this is used to find all the pairs with key value 4. So like it will return a pair of iterator of pairs. So like this is a iterator it return, and the first value will be like I'll just show in the code, you'll understand there rather than here. It has to return the elements with key values for this thing. It has returned the like I just wrote the second thing. You can check with. Yeah, 4 comma 40, 4 comma 45. I'll just insert one more element to make it a bit more clear. Okay, like 4 comma. Why is it showing error? Okay, wait. Oh, comma full stop. Yeah, 4 comma 40, 4 comma 45, and 4 comma 43. Yeah, as I told, you should note that they were not stored in the like they'll just store them in the order as we input, but not like in the ascending order of the value thing in the elements. Yeah, that's all about multi-maps. Shall we solve one question? this question might have multiple approaches, but what I want you to think is like, what is multi-maps approach for this question? A burglar got into a matches warehouse and wants to steal as many matches as possible. In warehouse, there are M containers. In the ith container, there are AI matchboxes, and each matchbox contains BI matches. All the matchboxes are of same size. The burglar's rucksack can hold eight max and matchboxes. Your task is to find maximum amount of matches that a burglar can carry away. He has no time to rearrange matches in the matchbox. That's why he just chooses not more than n matchboxes. So the total amount of matches in them is maximal. I'll give you some time. You can just think, and like if you get any idea, like you can unmute or put it in the chat. Yeah, there might be multiple approaches, but like if you get something like related to multi-maps, you can tell. Any doubts or approaches? I see. You understand. Okay. I'll just show for this, like as we are running out of time. What I want to do is I'll store this as key and this as like value for that element. And as it is multi-maps, like it can be 10, 10. And I want to store them in the decreasing order because like to maximize the amount of matches that like burglar can burglar can carry away. Yeah. Like N&M the thing question. This is like to store them in descending order. To store the key value pairs in descending order, we use this greater int. And like I'm inserting first I'll take A, B, and then insert all those pairs, and these will be stored as decreasing order. Like B will like values of B will be in decreasing order. Like I'll just go through all the elements and check if uh, if this is less than 7, then I will like take all these matches 5 into 10, total will be 50 matches. And if it is then I'll decrement the maximum by I'll decrement by this by 5 and then keep on checking. So what I have done is if x dot second, what is x dot second is like number of matches in the container, in the storing, in the order we store. This is to maximize, we have used greater here. And if it is less than or equals to n, what I'll do is answer is like to add the total matches we are taking away, x dot first into x dot second. Then I'll decrement the n by this and keep on like checking. And if x dot second is greater than or equal to n, at some point it will be like that. Then I'll just equate answer plus equals to n. Then we can take only n matches, right? There is a limit for that. So n into x dot first, and then I output the answer. Any doubts? You can unmute also. Yeah, I'll just submit it. I have submitted the same code, so it will show that thing. Yeah, got accepted. Any doubts? Any doubts in the topics we have discussed till now? I'll just go through unordered maps and then session will be over. It's like quick thing and you have to explore more like it. Okay, unordered maps. It is also an associated container that stores elements formed by the combination of key value as map value. Yeah. Here also like key value is uniquely identified. It is not like in multi maps. Here it is unique. The implementation, like the way we store here is different. Here we store using hash tables, and like you can know more about hash tables by googling. It's like complex to discuss. Yeah, the difference between like maps and unordered maps is like there was maps and multi-maps were like stored in binary in the form of binary search trees, and here we store them using hash tables. The thing we do, why we do this is like the time complexity of search, insert, and delete functions will be on an average O of n, O of 1, sorry. But like in case of maps, it is O of log n. Just to reduce the time complexity, we can use this. And like you can explore more about them. Like I have kept the links here. I'll just show the code for that unordered maps. It is stored in a random fashion, like using hash tables. Let's just run this code. Like I have inputted 5, 10, 3, 6, as well as 4, 8, 1, 2, right? Let you just check how like they'll get outputted. So first what came is 1, 2, and then like 4, 8, and then it went above 5, 10, and then 3, 6. Like we can't predict the way it will get stored. Like that is why they call unordered maps. Okay. Yeah, that's all I guess. any doubts, anything like till now or till in all the topics that were taught in the session, you can keep it in the chat. I'll just stop sharing. If you have any doubt, I'll just again start. Any doubts? Or we can end, I guess. Okay, I'll take it as no. Feel free to ask it if you have any doubts then. If you don't have any doubts, then you can leave, I guess. Shruthi, like, do you have anything to tell or something?
Not really. If you have any doubts in sets and multisets, you can ask.
Yeah,
And
that's what I'm thinking.
there's unordered sets as well. So I think that I leave it to you to search upon.
Yeah. Yeah, you can explore more about them. Like, there are many more functions in maps and like multi-maps. Like, you need not know them all, but you can explore. Like, they might be of some help. Like while solving problems. Yeah, that's all. That's all from my side. Okay.
Sir,
Yeah, you can ask.
sir, not related to this, but in general, for a code forces contest or any problem given, how much time should we be able to solve? Sir? On average, how much time is taking for?
It depends on the level of question and like the thing is like initially you will take a lot more time for even for solving the question. Yeah, like by practice, like the time you take for to solve like it will gradually decrease. It's like there is no limit for thing, but like if you practice more and more, then yeah, the time
Okay,
you
sir,
take for questions will be reduced.
so you ask more and more we familiarize or practice with all these maps, the vectors means we'll be able to develop speed and be able to solve for.
Yeah.
Okay, sir, understood. Thank you, sir.
Yeah.
Also, there will be like more functions than what we discussed here. So like in case like you think of a problem and you like realize that you can just Google whatever function that you want and then you'll find a syntax for it. So you need not remember all the functions that we taught here. Like you can always look up whatever function that you want in any of the STL containers and then you can use them.
Yes, ma'am. Thank you.
Any other doubts like in general also we'll try to cover like answer.